Jai Hind to all. Myself Dinanath Prasad, Department of Electrical Electronics and Engineering. The subject for the presentation is Energy Science and Engineering. Today I am going to cover thermodynamic cycle. In this lecture I will cover two thermodynamic cycle basically. First one is Rankine cycle, working of Rankine cycle, and another one is Carnot heat engine cycle. So let's see. As we know, the thermodynamic cycle is used to explain how the heat engine work, how to it convert the heat engine or heat into the work, and its applications determine basically which kind of cycle that are employed in any kind of engines. So there is a various different kind of thermodynamic cycles are available. The thermodynamics basically it consists of series of interrelated thermodynamic process, like it involves to convert heat into the work and with the body, and it work on the changing of pressure, work with changing of temperature, and it changes the state of the body, and after that for the completion of cycle, like it completing in closed cycle, it return to the initial state. So there is a different thermodynamic cycle, like it is tabulated here. One of the mostly widely used cycle that is known as Carnot heat cycle, engine cycle, Rankine cycle, Otto cycle, diesel cycle, Brayton cycle, and Stirling heat engine cycle. So these are the basic different type of thermodynamic cycle. First of all, I will discuss what is thermodynamic cycle. So as I said earlier, the thermodynamic cycle is a series of thermodynamic process or action that is carried out repeatedly, that leaves the system into the state when it is first created. So basically it work on closed loop cycle, or you can say this is closed cycle, has many process it is going on by the changing of temperature, pressure and volume, but whose end of the process or end of the cycle, that initial state are equal. The cycle is important because it allows the piston to the engine move continuously, and fluid working into the refrigerator and expand, compress based upon their whatever with the input is supplied to the engine. So first of all, I will discuss here the Rankine cycle. What is Rankine cycle? Rankine cycle is one of the thermodynamic cycle which work or convert heat engine or convert heat into the mechanical energy. By this process, it convert or transform electricity by the electrical generations. So this Rankine cycle was developed in 1959 by a Scottish engineer, J.M. Rankine. He has developed this process, that is the Rankine process. So in this Rankine cycle, Rankine vapor cycle is the process widely used in a power plant such as coal-based thermal power plant. It is used in nuclear power plant. It is used in nuclear reactor. So in this mechanism, fuel is used to produce heat into the boiler, and like in coal-based thermal power plant, and heat is produced in a nuclear reactor, and further it converting water into the steam, which with this steam we can used for the converting or rotating of the steam for the any kind of useful work. So these are the components of the Rankine cycle. Like you can say the component, first one component is boiler, then turbine, then the condenser, and the pump. So this four process is going repeatedly. This is the component of cycle I will discuss here with respect to the thermal power plant. Like in the boiler, heat will be acting it to boiling of the water, and that water is come out from that's it, pressurized water come from the feed water pump. Then whatever will be the steam, that is the saturated steam, will going to the turbine for the rotation of turbine. After the rotation of turbine, the steam, that is the saturated steam, basically used to rotate the turbine. After the rotating of turbine, some of the steam is wasted. If it is recycled, or if it is again we use, then we convert it into the water droplet with the help of a condenser, and this condensed water is again feed to the pump, and this cycle will be continuously processing. That is the process of converting input to the heat to the work done, that is known as Rankine cycle. If it is heat is input and the work done is processed, and we don't reuse this heat, then this is called the open cycle. So uh, there is a wasting of heat is also that, and that conditions the efficiency is very poor. So for the increasing efficiency, we will work on the closed loop cycle. Although the efficiency of Rankine cycle is not much higher, around 35% high of the efficiency of Rankine cycle. The efficiency of Rankine cycle or any heat engine cycle is depending upon whatever with the process, that is heat is converted into another form. So how much heat is available on this stream or that heated conditions, based upon that the efficiency is calculated. So this is another diagram which represent the Rankine cycle in the nuclear power plant. You can see this is the nuclear reactor. There is various nuclear reactors are available. This is one of the nuclear reactors are there for the generations of heat. Here again, heat will be generated in this nuclear reactor with the help of nuclear fuels, and then it is used to rotating the turbine, and this turbine is again be used to generate power further. But main issue is that if we reuse the steam, and that will be condensed with the condenser, and this condenser is again with the condensed water is again feed to the turbine, or feed to the this nuclear reactor, then this process is working on a closed loop cycle. So on that way, this heat engine is used to rotation, or heat engine is used for any kind of useful work for the electricity or any kind, and we reuse this heat, then this process continuously working. So this is the process of Rankine cycle basically. So further I will explain the complete step of Rankine cycle, like I will given you in with respect to the thermal power plant, that is pump, boiler, turbine, and the condenser. Pump is used to compression of the fluid of high pressure with the help of pump. Boiler is the compressed fuel heated into the final temperature for the work done, and the turbine, it expands the vapor into the turbine, and the condenser, the condensation of water into the condenser. So these are the process we generally we do in the coal-based thermal power plant. Now come to another cycle, thermodynamics cycle, that is known as Carnot heat engine cycle. So first of all, I will say the Carnot heat engine is not a actual cycle. This is practical cycle, or you can say thermodynamic cycle is also known as theoretical ideal cycle. So its state according to Carnot, it says this is the upper limit of the efficiency comparing to the any classical thermodynamic engine. So if we say the maximum efficiency, this is the of the any cycle will be the Carnot heat engine cycle. In any cycle, we comparing their efficiency with respect to the Carnot heat engine cycle. So that's why this is not a practical cycle basically. The efficiency of the refrigeration system. This is the basic structure to any heat engine cycle will work. Like this is operated in higher temperature. Let's suppose this is TH and TC will be the lower temperature. Its TH corresponds to QH and TC corresponds to QC, and W stands for work done. So if we going to calculate how much will be the work done by the any heat engine, that can be calculated as QH minus QC will be the work done. Similarly, if we say what is the efficiency, so efficiency will be calculated as work done upon what will be the heat will be supplied into the system, that is QH, or it can be represented as QH minus QC upon QH. Let's suppose the QH will be around let's suppose this is 800 joule and QC will be 600 joule. So work done according to that will be 800 minus 600 of joule, and the efficiency will be calculated as this is 200 joule. This is 200 upon joule upon QH is given 800. So based upon that we can calculate the efficiency. We will calculate this efficiency will be around 25%. So based upon that, what will be the heat input to the system, what will be the heat rejected will be to the system. Based upon that we can calculate the work done by the engine, and based upon that we can calculate the efficiency of any heat engine cycle. So we talk about the working of Carnot heat engine. This is working on 4-step, and or we can say in another term, this is 4-step process. First one is known as isothermal expansion, another one is known as adiabatic expansion, third one is isothermal compression, and fourth one is again adiabatic compression. So this Carnot heat engine cycle is work on 4 thermodynamic process or 4 process. In this case, in this chamber the ideal gas is fitted around this chamber. The heat will be initially, in initial case, that is in case of isothermal expansion, heat will be supplied to this chamber, to this isolated system. The heat will heat will be input will be supplied to the from the system. The heat will be expanded. In the second adiabatic expanses, the heat will be further expanded from there is a limit, that is TH, from TS to TL. The heat will be further expanses in case of adiabatic expansion. In case of isothermal compression, the gases is compressed from TL to this system, means heat will be supplied from the surrounding to the system. On that case, the heat will be rejected into the environment, and then this in adiabatic compression again heat will be added into the system. So this this Carnot heat engine cycle is working in this 4 process. Based upon that, for the better understanding of Carnot heat engine cycle, it is represented in a PV diagram and TS diagram. In PV diagram, like in process number 1, this process number 1 to 2, in this case, you can see the volume heat will be input to the system, the heat will be, the pressure will be decreased and volume will be increased. In case of process from second to third, the volume will be again increase. Volume of the gases will be again expand or increase, but their pressure will be decreased from this level to this level. Again, in another process, from process number 3rd to 4th, we as it is in working on the opposite direction, that is in isothermally, the volume of the gases will be decreased and the pressure will be increased, and in the process number 4 to 1, the pressure will be again increased and the volume is increase also. So this is the 4 process through that we can understand the PV diagram of Carnot engine cycle. In the TS diagram, you can explain again from the process number 1 to 2, the temperature will be maintaining constant, heat will be added into them, but entropy of the system, that is entropy is represented by S, entropy of the system will be increased. And the process number 2nd to 3rd, the entropy of the system will be constant, but the temperature is in this condition will be decreased. In the step number 3rd to 4, in case of isothermal conditions, the entropy will decrease and the temperature is almost constant. And in process number 4 to 1, the temperature will be increased and the entropy will be almost constant. So in conclusion, we can say the Carnot heat engine cycle is known as reversible isothermal reversible thermal it work on reversible isothermal gas expansion process. So in this process, the ideal gas system is absorbed, which is represented in the figure is Q in, and from the heat source at temperature TH, and this again the same process which is written here, that is isothermal reversible adiabatic, reversible isothermal, reversible adiabatic compressions. All processes can be explained with this TS diagram and PV diagram. So if we talk about the efficiency of Carnot heat engine cycle, the Carnot heat engine cycle is called as a reversible cycle, and this efficiency will be maximum comparing to any heat engine cycle. So this practical heat engine cycle is irreversible and that have inherently lower efficiency than the Carnot efficiency when operating at the same temperature. So this is the limit. One of the factor which determine the efficiency in addition to the working fluid is in the cycle and its removal. The Carnot heat engine cycle achieve maximum efficiency because of all the heat will be adding to the working fluid at the maximum temperature. So with that, the summary of this two engine, the Rankine cycle is a thermodynamic reversible cycle, which means that all the heat input may be converted back into the labor of work, and that will be friction, heat transmission, and other variable causes losses in the particle. As a result, the Rankine cycle efficiency is normally work on 30 to 40%, or generally it will work on 35%. The Carnot heat engine cycle is an optimal cycle and it has no genuine motor can be accomplished its effectiveness. In any case, the Carnot heat engine is a valuable hypothetical model and can be utilized. Look at the proficiency of various motors. So these are the references.